In this lesson, we'll go through an example problem involving a limiting reactant. When solving stoichiometric problems, in some instances there may be fixed amounts of more than one reactant. For example, you may mix a known quantity of oxygen gas and a known quantity of hydrogen gas to produce H2O. To determine how much H2O is produced, you must determine whether the hydrogen or the oxygen will run out first. The substance that runs out first is known as the limiting reactant. Let's look at an example stoichiometric problem involving a limiting reactant. 15 grams of calcium chloride and 30 grams of silver nitrate are mixed and react according to the equation below. What mass of silver chloride is produced? Let's write down what information we can gather from the problem. The mass of calcium chloride is 15 grams, and the mass of silver nitrate is 30 grams. What we're looking for is the mass of silver chloride. Since we're given the mass of two reactants, we know that we must determine our limiting reactant. To do this, we'll follow through with the mole method for both reactants. Whichever reactant produces a smaller amount of silver chloride will be our limiting reactant. We'll begin by converting the masses of both our reactants to moles. The number of moles of calcium chloride is equal to the mass of calcium chloride, 15 grams, divided by its molar mass, 110.98 grams per mole. This molar mass was calculated by adding the molar mass of calcium, 40.078 grams per mole, and 2 times the molar mass of chlorine, 35.45 grams per mole. Our grams unit cancels out, and we're left with 0.1352 moles of calcium chloride. Now to follow the same steps for silver nitrate. We take our mass of silver nitrate, 30 grams, and divide it by its molar mass, 169.87 grams per mole. This molar mass is the sum of silver's molar mass, 107.87 grams per mole, nitrogen's molar mass, 14 grams per mole, and 3 times oxygen's molar mass, 16 grams per mole. This gives us 0.1766 moles of silver nitrate. Now we can convert between moles to see which reactant produces the smaller number of moles of silver chloride. First, we can write the number of moles of silver chloride is equal to the number of moles of calcium chloride, 0.1352, multiplied by the molar ratio 2/1 from our chemical equation. With the moles of calcium chloride canceling out, this gives us 0.2704 moles of silver chloride. Now to do the same with silver nitrate. We can write the number of moles of silver chloride is equal to the number of moles of silver nitrate, 0.1766, multiplied by the molar ratio 2/2, once again from our chemical equation. This just gives us 0.1766. Since this is lower than 0.2704, we know that silver nitrate must be our limiting reactant. Now that we know our limiting reactant, it's on to our final step, converting from moles. We can write the mass of silver chloride is equal to the number of moles of silver chloride, which we know is 0.1766, multiplied by the molar mass, 143.32 grams. This molar mass was calculated by adding the molar mass of silver, 107.87 grams per mole, and the molar mass of chlorine, 35.45 grams per mole. Doing this, the moles of silver chloride cancels out, and we're left with 25.31 grams of silver chloride produced.